R-CADT is pleased to invite you to participate in the course group Applied Operations Research and Industrial Engineering. Operations research uses the scientific method to address organizational problems, focusing on providing management with a mathematical basis for decision-making. It is not a science, but more the application of science, logic, mathematics, statistics, and various theories to managerial and administrative problems. It focuses on organized systems, using interdisciplinary teams of scientists and engineers. Operational research began in 1937 in Britain and developed in countries such as Australia, Canada, France, and the United States. Smart computing, the new era of computing. Analytics is one of the pillars of the so-called smart computing. This is based on the statement of Andrew Bartels of Forrester Research, who in the study Smart Computing Drives the New Era of IT Growth, December 2009, states, "Smart computing is a new generation of hardware, software, and integrated network technologies that provide IT systems with real-time, real-world knowledge and advanced analytics to help people make smarter decisions about alternatives and actions that will optimize business processes and balance sheet results." From the above, it can be deduced that optimization based on mathematical models is a great business opportunity in first world countries and in developing countries. Franz Edelman Award for Achievement in Operations Research and Management Science. For more than 4 decades, Edelman Prize winners have been recognized for transforming the way they tackle some of the world's most complex problems. For 2022, the Edelman Prize finalists have contributed to a cumulative impact of more than $292 billion since the inception of the prize. The fundamental support of intelligent computing is the mathematical modeling of the organization, which has produced billions of dollars in profits. From the above, it can be deduced that optimization based on mathematical models is a great business opportunity in first world countries, and in developing countries. This is what is now called decision-making artificial intelligence, which is the integration of operations research with artificial intelligence. Since, in fact, operations research applications have always been artificial intelligence. Despite the economic impact of mathematical modeling projects, the commercial development of this business has been slow in non-industrialized countries, both in the creation of startups and in the use of optimization models. Structure. The group of courses aims to train the participant in the main problems that need to be solved in the planning and advanced programming of value chains specific to industrial engineering, and more generally to engineering. It is made up of 4 courses in applied operations research. Industrial supply chains. Agro-industrial supply chains. Demand chains, and transport and logistics chains. Courses can be taken all in a group or individually, depending on the student's interest. Optimization of industrial supply chains. Training in the problem of supply chain optimization, concentrating on optimizing decisions on how to optimally produce commercial products and/or byproducts offered by general industrial sector chains and the special problems posed by manufacturing industries. The following types of models are studied: designing robust and resilient supply chain, sales and operations planning, SAND-OP, inventory policy optimization, global procurement optimization, production scheduling, maintenance scheduling, scheduling of human resources to production activities, assignment of products to orders and orders to trips, available to promise, ATP, and distribution schedule. Optimization of agro-industrial supply chains. Training in the problem of agro-industrial supply chain optimization, focusing on optimizing decisions on how to optimally produce the products they offer. The course focuses on primary link optimization, farms and ranches, and its coordination with secondary link factories, value-added industries that use the animals and/or plants produced in the primary link. The following types of optimization models are studied: sowing and harvesting planning, farm network planning, feed sourcing planning and scheduling, harvesting of crops and animal cohorts, allocation of slaughtered animals to commercial products, available to promise, planning of seasons with super peaks of demand, synchronization of the primary link with the industrial link, and biomass energy generation. Demand chain optimization. Training in the problem of optimizing the demand chain for industrial products and services, focusing on the characterization of demand, mainly its elasticities, knowledge of the competition, market share, and the decision-making process in such a way that it affects the process of driving demand, with the aim of producing greater economic gains. The following types of mathematical models are studied: demand forecasting, market potential, market share projection, optimization of the marketing mix and market share, price optimization, revenue management, inventory policies, and product portfolio management. Considering the digital transformation of companies, it includes the modeling of social networks with the aim of knowing the behavior of customers and relating them to digital marketing and e-marketplaces. Transport and logistics operations chain optimization. Training in the problem of optimization of the logistics and transport chain, concentrating on the modeling of modern multimodal transport systems, trains, ships, planes. The following types of optimization models are studied: optimization of routing problems, such as TSP, travel salesman problem, and VRP, vehicle routing problem, and their continuous time modeling to produce detailed schedules. Optimization of brokerage prices in LTL, less than truck, type transport systems. Optimization of special transport systems, ships, planes, trains and truck fleets. Optimization of logistics operations in the environment of ports, airports and railways. Optimization of multimodal transport systems, and optimization of the processes of buying and selling products in international markets. Applied operations research and industrial engineering. Aimed at professionals, engineers, mathematicians, physicists, consultants, economists, data scientists, software developers, etc., who require and or wish to know mathematical modeling, advanced analytics algorithms, related, among others, to the implications of Industry 4.0 and its relationship with the process of evaluating the technical economic impact of the decisions that are made. This continuing education program strengthens the analytical skills and professional criteria of the participants, so that they can exercise, share and or supervise, with propriety, the professional functions in accordance with the state-of-the-art of the methodologies and technologies that support the digital transformation of the companies. Mathematical methodologies. Mathematical methodologies correspond to the scientific foundations for implementing mathematical optimization models. Specific objectives: training in fundamental methodologies to support modern mathematical modeling. To train so that the mathematical modeling of industrial and business processes is a generator of real socioeconomic wealth frequently used in our society. Understand that optimizing the use of resources is the scientific basis of sustainable development. Learn about systems and industrial market modeling. Learn the fundamentals of modeling real problems based on the integration between mathematical models and data models. Information technologies. Computer technologies correspond to the computer tools available, freely or commercially, to design and implement solutions to problems in social or industrial organizations. Specific objectives: learn how to implement solutions applied in the real world by making use of the modern computer technologies available for the algebraic modeling of industrial and business systems. Present and manage live tools used by large companies to solve their optimization problems. Understand the state-of-the-art of optimization and its relationship to smart computing. Know the available technologies, as the principle of basic knowledge to be able to solve, in reasonable times, problems with millions of variables. Know the fundamentals that must be had for the assembly of models using the most effective technologies. Value chain optimization or enterprise-wide optimization. The diagram presents the chain of the company's production chains that together make up the value chain. One of the greatest evolutions in the modeling of companies occurs in the interpretation of their value chain. The first step in business modeling arises with mathematical models of industrial processes, which are characterized by their complexity, with very little interrelation between them. In this aspect, with a very simple vision, it can be said that the mathematics of industrial processes do not change, that what is constantly changing is the power of information technologies. This is followed by ERP, Enterprise Resource Planning, which in its initial versions do not access mathematical models. ERPs evolve in two systems. SCMs, Supply Chain Management Models, aimed at optimizing the production of companies. And DCMs, Demand Chain Management Models, focused on sales and marketing management. The union of the two modeling systems produces the Sales and Operations Planning Model, S&OP. Advanced versions of S&OP are optimized in an integrated manner as a single model, and not by coordinating two models. The first option is the most effective. The Integrated Business Planning Model, IBP, includes the financial chain and the company's planning. The evolution of this paradigm of technological tools is presented in the diagram. Thanks to computational power, the integration process has continued to grow. The diagram presents the original S&OP model, and the current version, which integrates more and more models. There are multiple points of view to analyze the planning and programming of production chains. The second aspect is the hierarchy of decisions, that is, their coverage over time, according to their impact and the characteristics of the models to be used. The first two levels are strategy and tactics, which fundamentally analyze the long and medium-term impact. At the bottom of the hierarchy is programming and advanced real-time control. Today, thanks to IoT, a new application has been created that is real-time tactical planning, which did not exist before. This involves adjusting the tactical planning of the chains as impact events occur in the medium term. Another point of view is the regional one, which is necessary in global production chains, which must be coordinated in space and in the global transactions they carry out. State of the art in 2021. Robots, algorithms, can autonomously and automatically perform specific processes with pre-established coordination, limited intelligence, and little interaction between robots. The robotization of powerful processes in real time, supply chain planning, operation of production plants, optimization of traffic systems, coordination of marketing campaigns, etc., is relatively unwidespread. Today's computing power based on the unlimited availability of processors offers electronic computing capabilities at a completely different level than in the past. Industry 4.0. Robots capable of autonomously carrying out high-coverage processes based on intelligent interconnection, mathematical conversation, between robots using information from big data systems, based on IoT. The current state of technology can be synthesized at the confluence of computer parallelism and complex mathematical modeling. Only companies that fully understand and manage the interrelationship between these pillars of socio-economic development will be able to fully participate in the generation of knowledge required by Industry 4.0. Enterprises can't take advantage of the availability of hundreds of thousands of processors if their analytical tools can only organize high-level mathematical calculations around the monolithic concept of a single processor. This evolution has led to modeling based on artificial hypothalamus, supported by the integration of mathematical programming and artificial intelligence. Finally, decision-making artificial intelligence is a new term, coined by High to refer to optimization algorithms aimed at decision-making. It could be said that its birth coincides with the launch of the ENIAC computer, in 1947, which gives voice to digital iterative algorithms such as the simplex method, created by Danzig. It is very little known, and there are very few companies specialized in this area of knowledge. High is one of them. High has accumulated 50 years of intellectual property in this field. The power of today's technology is not in the mathematical calculations it allows to be performed, it is in the mathematical calculations we can imagine we can perform. The course group director is the founder and executive director of RCADT. Engineer Velasquez Bermudez's experience in applied operations research dates back to 1972, which means that he has accumulated 50 years solving real-world problems doing engineering consulting using mathematical models. R-CADT is the most applied academic center in the integration of the teaching of mathematical programming and artificial intelligence. For more information, you can consult the URL. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.